Hi, I'm Larry Puckett, the DCC guy. For a long time, people have been asking me how they can build control panels that are controlled by DC power and not by accessory decoders, a DCC, anything like that. They just want something that is completely independent from the layout that runs off of straight old DC power. So today we're going to be taking a look at how I built this control panel right here for the Lynchburg switch machines. And I'll tell you right now, it runs off of DC power. There's nothing DCC at all about it. So you can use it on any model railroad that you might have, no matter what the power. It can be AC, it can be DC, it can be DCC, or any other type that you manage to come up with. So let's take a look at how you can build a control panel similar to this one for your model railroad. Several years ago, I did a series of 5 videos on how I build control panels for use here on the Piedmont Southern. Now, one of the things that was very different about the control panel in that series of videos compared to what we're going to do today, and this one right next to me here, is that it was designed to work with DCC accessory decoders. But the one that I'm standing next to right here is a little bit different because it operates off of DC power. And one of the things that is very different about this one is that it uses toggle switches. And those are important because they control the polarity that is fed to the motor in the switch machine and therefore controls which direction the points are thrown. Now, in addition to that original series of 5 videos, I also did one more recently, number 209, that looked at how to use DC power in this type of arrangement. So at this point, I've already covered how to go about designing and building control panels, and I've also covered the method for using DC power to control your switch machines on your model railroad. So everything that you need to build a control panel, like the one I'm going to show today, is already available to you on my channel. In addition to that, the instruction sheet that comes with your Tortoise switch machine actually shows you the same thing. Right here on the back in diagram number 3, it shows you exactly what I did in order to provide DC power for this control panel and how to wire it up. So it's all right here. And right here next to that in panel 4, or diagram 4, it shows how I use LEDs on the control panel as well. As many of you know by now, as I've been saying for several months now, All Electronics, which is the company I've been recommending for years now for parts, has gone out of business. The owners retired and shut the business down. I just found out the other day that a group of ex-All Electronic employees has started a new business, and it's called aretronics.com, and they're selling a lot of the same materials that All Electronics was selling. Unfortunately, they just got into business, so they're still stocking up, but they do have a website up, and they're starting to bring on a lot more products. So they're going to be expanding more in the future. So they're a very good source for parts like this now that All Electronics is gone. Then take a look at a company called Jameco, Jameco.com. And they are a very good source for all of the electrical components and wiring that I use down here on these videos. And you can also find that kind of stuff on eBay and Amazon, things like that. Okay, so what are we going to do today? Well, first, I'm not going to show you how to build the control panel that I'm going to be working on, because as I said, I showed you that in videos 22 through 26, still available on my channel homepage, as well as how to wire them in video 209. So all of those are readily available. All you have to do is go to my channel homepage or channel page and do a search there for model railroad control panels, and you should get 22 through 26 coming up. And you can also look up video 209 for powering Tortoise switch machines, and that will bring up that particular video. And that way, with this particular build, I don't have to do 6 videos to show you. I'm only going to do one, and I'm going to keep it as short as possible. Okay, what I want to do now then is bring you in here real close and show you what I've been doing here on the panel. Because I've got it built for the most part, and I've already pre-wired most of it. So I want to show you that before we get down here and start doing some soldering to finalize it. Okay, I've got this temporarily wired here so that I can show you how it works. So before we go ahead and finish the soldering here, basically the green lights indicate that this is the normal path of travel. So that this would be the default orientation for the switches. So you want your turnouts thrown so that you can go straight through on your main lines until you get down to here. Now, in order to cross over from the southbound main to the northbound main and go down the helix, you want to throw that switch using that toggle. And that red indication there indicates that this is now set for this route. And so one thing that I can tell my operators is anytime that they've been working in an area, if there's a red light showing on the control panel, make sure that they cycle that switch back so that you don't have a red showing. You always want the green path to be active unless you're actively using that other path. And that's true for any of these. This is the path that goes off to Lynchburg Industrial Area down by the river. So that's the way that I design control panels. Now some people like to use the same color. Some people might want to use a bicolor LED and just have it go one way or the other. I particularly like this method because it gives an indication of where the active track is. Plus, it also gives you that red warning signal to tell you that you've got to do something before you leave this control panel. So let's go ahead and I'm going to flip this over and we will finish off with the wiring on the bottom. Now, even though I said in video 209 I showed you how to do the wiring, I do want to quickly go over this because it does appear complex. Now, you'll see a yellow wire and a blue wire. Now, those are the two wires that come from the DC source. So they bring in the positive and negative power to the device. Then I have these single pole double throw switches, and the plus and minus wires are attached to the two end poles. And then there's a single wire that comes out here that will carry either plus or minus depending on which way the toggle is thrown. So it's a very simple approach. And I've used the same thing in here. You can see the yellow and the blue here. And there's also yellow and blue back here. So I've brought the two wires in, connected them to this particular switch here, toggle switch here, and then just simply daisy chained it to the next one in line, as you can see. And that way you can make your connections with the smallest amount of wire possible, and it's a lot easier that way in the long run. So that's what those are. Then these black wires are the wires that are going out to the various switch machines under the layout. And when I did the pre-wiring of my Tortoise switch machines, I used white and black for the power wires connections for the Tortoise switch machine. There are several places in here where your polarity can get messed up. So the first thing, you've got the plus and minus wires coming in and connecting to this single pole double throw switch. So it's only by trial and error that you're able to find out which set of poles it should be attached to. And then when you go out from the center pole, that connects to the LEDs. And again, I showed how to wire those up in video 209. So you've got to check your polarity when you're coming in here to the single pole double throw switch. You've got your polarity going to the LEDs, and then you have a feed that goes out and goes to your turnout. And when it gets out there, then you have to do a polarity check as well. And that's where having a bunch of these small mini jumper cables can come in very handy, because they allow you to take one of these connected at two different points and make temporary connections. So as you can see here, I've got a temporary connection of the yellow from this connection here point over to this point here on this single pole double throw switch. And the same thing with this black wire here. I'm using it because I don't have a blue jumper cable. But at any rate, that's what I've done. I've used the black to make this connection between the blue wire here and the blue wire, where the blue wire will end up being attached here. So that's one of those things where as you build this, you have to have a bunch of these cables in order to test your configuration, test the polarity before you make your final soldered connections. So right now, I've done this one, I've done this one, and I know they work. So the last one that I need to make an attachment to is right here. I need to add a yellow wire, I need to add a blue wire down here, and then I've got a black one here, and that goes from the output on one of these LED pairs to a black wire that disappears and goes off to a turnout. Now I hope that's clear, but again, go back, look at those videos 209 and 22 through 26, and they will cover all of these details of wiring these LEDs up. Hit that little red subscribe button, and when the little bell comes up, click on it and click all. What I want to do now is crank up the soldering iron, make these final connections here so we can get that out of the way, and then we'll look under the layout at how I made the connections there. Now, I've already been through all of the testing with the clip leads, or my jumpers, and I know that the configuration as it is here is what is correct. So I'm going to take the black wire that feeds out to the last of the Tortoise switch machines, and I'm going to make its connection here to the LED output. Okay, so that one's done. Now, let me get my yellow wire, and we'll cut a section, a piece long enough to do that. So it only has to be, looks maybe that long. And I'm going to strip off a little bit. Okay. And we will pre-tin it. Okay, that one's tinned. Now we'll get this one. Okay, so we've got the two ends tinned. Now we can make the connection here. What I'm going to do is put a little dogleg bend on each end here. Like that. And then I'm going to disconnect the two clip leads. Let's do this one right here first. Okay, that one's done. Now, I think I'll solder left-handed. This could be dangerous. There. Now I'm going to remove this and do the blue. By the way, I did check, and AR Electronics does have these mini clip leads just like these here. I think you can get 10 of them for $3.90, so 40 cents for each one. It's a bargain. So now I need to get my blue wire, and we will strip a piece of it, prepare it. And how long does this need to be? I think it needs to be a bit longer. It's going to be about that long. And need to strip a little bit of insulation off of that wire. Okay, so that's going to be run between here and here. I think I'm going to attach it down here first. Okay, and then I'm going to bring it up here and attach it to the bottom here, hopefully. And that will hold the other blue wire in place. So now we have the yellow and the blue wire done, and we have the black wire done, and everything else was connected before we got started here. So that's the way it's set up at this point. Now we can turn the power back on in a minute and see if this is going to work. But first I want to show you how I've got this set up here. In order to provide a place for the wires to get into the control panel, I simply drill a hole in this shelf. So that's about a ½ inch hole, something like that. And then everything will just slide neatly into place. And then the control panel will sit here flush on the shelf and up against the fascia. And then I will put in a couple of screws coming up through the bottom of this shelf into the two sides, and that'll hold it in place. And you rarely ever have to open these, but it's a simple matter to back out 2 screws to get access and pull this out and set it up if you need to work on it. Now this one is a little bit more difficult because it's such a small control panel. The other control panels here on the layout are larger. This is the smallest one. Okay, I'm going to put this into place, and then we'll take a look at how things are wired underneath of the layout. Okay, so this is turnout number 1. At this point, if you remember, I used black and white for my 2 power wires for the switch machine. Now this white wire here is the common wire that comes from the power supply. So it feeds down here to the turnout, but note that it is connected to the black wire. That's because when I did this, I always follow the same convention when installing these black and white wires. So when you get in a situation where the polarity is different, you just have to go with what's there. So in this case, I've got the common wire attached to the black, and then the white wire from the turnout is actually connected to the black wire, the polarity wire coming from the control panel itself. So that's one of those cases where your best laid plans sometimes don't work out when you're selecting the wires in advance for pre-wiring your Tortoise switch machine. All this does is the common wire is connected here, and then the polarity wire plus minus wire is right here. So that throws the turnout when you flip the toggle and change the polarity that's being fed to the motor. Let's go ahead and look underneath of the layout if I can get under there. Now that you've seen the first Tortoise switch machine, let's take a look at how I wired the second one and the crossover. So this is the Lynchburg spur turnout that takes you out to the to Lynchburg proper. And you can see I've got the white wire, and in this case, the white wires actually aligned with the white wires that I installed on the Tortoises. So I got lucky on this one as far as polarity. So I've just simply taken a white wire here, brought in the common wire from the power supply, hooked those through a Wago connector, and daisy chained it to another Wago and connected that to the next of the Tortoise switch machines, and then so on forward to the last one, again using another Wago. So again, we've got the white wire providing the common connection to all of these Tortoise switch machines through that white wire leading up to the Tortoise switch machine itself. So right here you can see this wire here. I've done a quick splice connection. This is the wire coming from the control panel that controls the polarity being supplied to the Tortoise switch machine. So that goes on in here and controls that Lynchburg spur turnout. Now this one here, you can see it comes down, and then I've used another Wago here. So that one goes to supply power of the correct polarity to this first turnout in the crossover. And then I'm able to take that wire out using the Wago and take it to the next one in line. And as you can see, I got lucky here too, because again, I used a Wago and was able to connect it to the black wire on the Tortoise switch machine. So everything came out polarity-wise fine here. So those work great. So basically, it does take quite a bit of testing to make sure that you get the correct polarity at each of those 3 steps. You've got the polarity connection at the single pole double throw switch on the control panel. You have the polarity connections for the correct direction on the LEDs, and then you have to get the polarity correct being fed to the actual Tortoise switch machine. And once all 3 of those are lined up correctly, it'll work fine. But again, you just have to make these temporary connections and test them, see if they work. If something's out of sync, you have to go back and make the change in order to get them in sync. Okay, so now that it's fired up, you can see everything's lit, so I didn't short anything out. Let's throw some switches and see if they work. So right here is the turnout that leads off to Lynchburg. So let's throw that. And you can see it's now turned nice bright red. And now you can see it's throwing from the mainline position to a route out to Lynchburg. So let's throw that back. Now let's take a look at the crossover right here. Throw that, and the green lights have gone out and we're showing all red. Throw that back. Okay, so we can watch the crossover. And hopefully you can see those points move. So it's working exactly as the lights indicate. So everything is in sync. And that's always one of the concerns you want to have, is that your toggles are in the correct position. So I set my toggles so that they are for the main line here. So you can see it switched for green for the main line. This one is up for the main line. This one is facing up for the main line. Now if I throw it down, then it shows it's going this way. So that's one way that you can sync these. Some people might not care whether it's pointing up or down. And so that's one less point where you have to worry about the polarity. But the way I do it, I have to worry about the polarity setting and the direction of the switch toggle itself. I also have to worry about whether or not the red and the green are showing up at the correct time, and also whether or not they are in sync with the Tortoise switch machine, which is going to control the direction of the train travel through here, because you don't want a switch actually thrown when it is showing green or something like that. So those are the kind of things you have to watch out for when you're putting these together. Well, that's a wrap for today's video on building the control panel for the switch machines here at Lynchburg. So the next time that you need to build a control panel and you'd prefer to use DC power instead of using accessory decoders for DCC, then this might be the way that you consider going, because it does make it quick and easy to be able to flip a switch, see the direction of travel that the locomotives are going to go, and get it done in a reasonable amount of time for a fairly low cost. So that's it for today. Have a great weekend. Have a great week. I'll see you here next week with another video from the DCC guy. Bye now.